Hi, thanks for joining us today. Today we're going to be talking about lesson 9-5, which is integration involving the inverse trig functions, or just simply put, inverse trig integration. In the last lesson, in 9-4, we covered the fact that the derivative of arcsine would be u prime, the derivative of the inside, divided by the square root of 1 minus u squared. Whereas the derivative of arctan is u prime over 1 plus u squared. So if we anti-differentiate, if we go take the integral of these right-hand sides, we should get the left-hand side. It should undo the derivative, anti-differentiate. And we should get that the integral of something that looks like this would be arcsine, and the integral of something that looks like this would be arctan. Now, we're not going to go over the specific derivation, but this brings us to our last two trig rules. Now, the only way these two are different is this a squared here and the a squared here. And that'll show up as just a in the bottom. Now, notice arctan has 1 over a on the outside, arcsine doesn't. And again, the way this rule is different, we have a squared instead of 1. So both of these rules work with any number here, any square here, and we're going to be good to go with either of these two rules. So in general, we're going to be on the lookout for something over a square root of a difference of squares and something over a sum of squares. I also want to point out that the u part, just like it's always been denoted, has the x's in it. So u has the x's, because the order here matters. It'll be pretty clear from the minus sign here which one's u, but here the matters that u has the x's, has the variable in general, t, x, whatever. We also don't have a rule for arc cosine because their derivatives only differ in terms of sign. So we're not ever going to see integral of something equals arc cosine. We're only ever going to see integral equal arcsine or integral equal arctan. Now, as has been true ever since chapter 9 began, the hard part is knowing which is which. The hard part will be distinguishing. But while we won't go over these rules in general, how these rules come up in general, we'll show a specific example of why we can have these rules with a's, not just the ones. So as a warm-up, please take the second to differentiate both sides of this equation. You should be able to do this without your notes if you've been studying correctly. If you have to peek, go ahead. Try the problem out. 3, 2, 1. I hope you didn't have to use your notes. So the derivative of arcsine should be, again, basically u prime over the square root of 1 minus u squared. Okay? That's what you should see when you hear about the derivative of arcsine. When you think about the derivative of arcsine, where u is what's inside. So we have, I'll do the bottom first with a great straight line. I don't like that. Square root, not big enough. 1 minus, just put the inside, squared. And on the top, we should have the derivative. Sorry, I almost forgot the label. Shame on me. On top, we should have the derivative of x over 2. X over 2, the derivative is just 1/2. Now again, I've said this before recently, if you think you have to use the quotient rule to do that, that's really a bad sign. You need to know that whenever we just have a variable with a constant, we can just take the variable's derivative. It might help you that x over 2 equals 1/2 x. Like, that's the same notation. So what's the derivative of 5x? 5. What's the derivative of 1/2 x? 1/2. Now, it's not clear why this should be anything useful, but we're going to simplify this a bit. So dividing these two fractions, and again, it's this fraction divided by this square root. you should get this. And it's okay if you didn't simplify it, but it's not okay if you couldn't get this. 1 minus, let's simplify x over 2 squared. That's x squared over 4. And that's all inside the radical. I knew that was going to be a too big of an eraser. So we have a 1. Okay. We have 1 minus this fraction. And we can bring 2 inside the radical. This part always confuses students. But I can write 2 as root 4. That part shouldn't be confusing. They're equal, so I can replace them. And then 2 roots like this, I can distribute one root into the other and get the square root of 4 minus 4 times x squared over 4 is x squared. So that's a simplification of the derivative of arc sine. And that's why this rule is going to cash out. We can have any square here minus x squared. So for instance, why did we do all that? If someone asks you to integrate 1 over the square root of 4 minus x squared, now we just did this work. If you see where this is going, just take a second. What do I notice? How do I notice this arc sine? Well, I don't really have anything else going on the top. Something we need to be on the lookout for is reverse power rule, but I don't really have anything to hook off on the top. And in general, I would notice I have a difference of squares. It looks like the square root of a squared minus u squared. And if this is a squared minus u squared, I would say, oh, a equals 2, u equals x, right? And then that would be 2 squared and x squared. So then we need to figure out what u prime would be. Oh, u prime would just be 1. Perfect. So there's my hook off. And I get this integral is equal to arc sine. That does say arc sine if you can't read cursive. U over a plus c. And that's why this rule works. It works because the derivative of this needs to leave that. We just checked it. You could prove the rule with a's. We're not going to do that. It's not really necessary. You just have to know how to use the rule. Next, if you feel like you have the hang of it, go ahead and try this one out. This is going to be the last basic one, sort of. 3, 2, 1. So again, why do I know this is going to be an inverse trig? Because we're just over a sum of squares. Whenever I see a sum of squares or a difference of squares inside the radical, your spidey sense should tingle and you should be thinking of arc sine or arc tan in general. If this dx on top bothers you, I know that always bothers students when they first get started in this course. It's been a while, you should have gotten used to it, but whatever. You can move it aside. Don't let it bother you too much, guys. Not 2x, 25. Okay, you can just move it outside. That's fine. They're both, it's going to show up. You need to know how to deal with it. So then I notice I have a sum of squares. So if this is like a squared and u squared, which one's u? Well, u is the one with the variable. I wrote that on the last one. U has the variable. Oh, this is awful handwriting. U has the variable, so u, in this case, would be what? Now again, don't say 4x squared. U is going to be 2x, because this should be u squared. And that should be a squared. So if u squared is 4x squared, then u is 2x. You can take the square root. You can do this any number of ways. Most people just see it. Just like you see a is 5. So if we're talking about u squared and a squared, we're thinking of arctan. It's important to know what u prime should have been then. U prime should have been 2. So I need a 2 for a hook off. So the idea here is to take that integral and I'll bring out a 1/2 so I can have a 2 on top. And that way, I'll have a u prime over u squared plus a squared, or a squared plus u squared, however you want to cash it out. And that's exactly what I need for arctan. So I'm going to have a 1/2 times 1/2 arctan 2x over 5. Oh, I'm sorry. It shouldn't be 1/2 times 1/2. 1/2 times 1/5 plus c. Now, why this 1/5? It's because, again, arctan has that rule 1 over a needs to show up. A lot of people think this 1/2 counts. That's kind of why I made the mistake. The 1/2 is different. I needed the 1/2 for the hook off. I got the 1/5 because that's 1 over a. Okay? That's easy. This is simplified to 1/10. Don't bring anything into here. Good to go. Next. All right, now I put all three of these next to each other for a purpose. And if you look at it, I think the purpose should be clear. It's because, as you might be able to see, they each look alike. This is the start of the look-alike problems. We had similar things going on with natural log before. And each of these problems need to be addressed differently, even though they look similar. Now, how do we tell which is which? Because they won't always be next to each other, so you won't always know which one's which and not to use the same formula on all three. Although, if you're weak with this, you won't know even if they are sitting next to each other. I have seen students do all three of these with natural log, which is wrong. So why don't you pause, each of these has a different formula, and try to figure out which formula to use. You don't have to worry about getting it right now. Just try to pick out which one do you think is which. If you want to, try to actually integrate. They're all different. 3, 2, 1. Here we go. So what do I notice here? I notice that I have no x's in top. That kind of matters. You'll see why in a second. I also notice that the bottom has at least one square in it. So something I should be on the lookout for always is natural log. Natural log, we would just check the derivative of the entire bottom. I'm just showing you how this would go. It's not natural log. If the entire bottom was u, then u prime would be what? 8x. Ooh. Anyway, so that's not on top, and I can't get an x. So that's how I know this is not natural log. It's always easy to take the derivative of the bottom as long as there's no square root or group to a power. So you should always do that first. That's really how I work. So now I'm saying, okay, it's not natural log. Let's try arctan. So arctan, we want this to be a squared plus u squared. Now, calculus students should be aware that if this is a squared plus u squared, there is a way to get the square here. You can just take the square root. What's the square root of 3? Oh, a is going to be the square root of 3. Yes, that's okay. It's harder, but it's okay. U is going to be 2x, just like in the last example. And that would make u prime equal to 2. So I need a 2 on the top. There's a number of ways to get 2 on the top, but you should be able to get to this form. I'm going to get 2 on the top by factoring out a 4. You could have multiplied by 1/4 on the inside and then the reciprocal of 1/4. However you want to think about it, it's okay. And we're going to have this kind of thing going on. So this pretty much worked out. If u prime is simple, if u prime is a constant, this kind of trick will work out. So now we have 4 times what? You should be able to do this. If you haven't paused the video and try this out, please take a second. 3, 2, 1. All right, so we're going to have 1 over the square root of 3. Yes, that is okay. You don't have to rationalize that. Arctan of 2x over root 3 plus c. And again, just in case you get freaked out and say like, oh man, my answer is not in the back. 4 times 1 over root 3 is 4 over root 3. This is an acceptable final answer as well. It would also be acceptable to say tan inverse instead of arctan, but that notation is confusing as we discussed in the last video. Either of these two answers are okay. I would stop here because God forbid you do something awful. I won't even say what. All right, so I kind of alluded to this in the last problem. You should try this out. It kind of gave it away. Try this out. Try number 5 out. Again, number 5 is different. Number 5 is different. 3, 2, 1. Okay, for number 4, the first thing you should always try, like I've said, is what if the whole bottom was u? The whole bottom was u. What if the whole, just the bottom, was u? Then u prime would be 8x. What? That's already on the top, so it's a hook off. So now we have u prime over u. It's a u prime over u form, so this is one of those ones you should be able to do instantly. Done. And it looks so simple because it is. It was set up to be done this way. Sometimes you might have to mold the top into u prime, but in this case we didn't. If you need a refresher on this, this is lesson 7-5, 7-6, one of those two. Important stuff. Let's use a nice dark green. All right, now here, again, if you start the whole bottom as u, then u prime equals 8x, not 8x squared. And before you start doing something like x, factor on x, that doesn't work. Get those thoughts right out your head. And if you look back over here, like if we try a squared plus u squared on the bottom, then u equals 2x and u prime equals 2. And again, we have a similar problem. We can't get rid of the x. So this is the one I would have expected you to get stuck on. Well, now that it doesn't fall into one of my basic ones, and again, that's what's sad for you. Arctan, arcsine have to become basic, have to become simple for you. Now that it's not one of my basic ones, I'm going to try a technique. Boo on you, it's not this. Don't write this down. If you did this. This is not an okay kind of splitting. That's not how fractions work. You know that. You can't split up the denominator. You have to split up the numerator, keeping the denominators the same. So splitting is not the right answer here. Moving this to the top is not okay because it's a group to a power of 1. So moving that to the top will never be the answer. What you might notice is that the degree of the denominator matches the degree of the numerator. So this is a long division problem. The degree of the denominator is 2. The degree of the numerator is 2. If the degree of the numerator is bigger than or equal to the degree of the denominator, we should try long division. So I'm going to reorient and keep the highest power in front. And I'm going to put the top dog in the doghouse. And going over the long division one more time. Again, if you need more practice on this, please come see me. We can do a lot of practice for long division. It's not that bad. I want to match this front guy to 8x squared. What do I need to multiply by? To get that, I need a hot pink 2. 2 times 4x squared plus 3 is 8x squared plus 6. And remember, we're subtracting the entire group. You should distribute that negative. I can do it mentally. Can you? And when we subtract 8x squared minus 8x squared, that'll be 0. I'll change colors again to a nice royal purple. 8x squared, sorry, and then 0. 0 minus 6 will be negative 6. So the remainder is negative 6. So this whole integral, and it's okay if you write arrows like this. I'd rather see the flow of your work than be mystified. Is the quotient? Sure. The quotient, this will always work, plus the remainder with its sign over the original divisor, the original numerator. Matchy, matchy, matchy. Okay, and that just is true. This too is not over a denominator. And now we're just integrating this guy. So the integral of 2 is easy. I got you there, 2x. What's the integral of this? Might be complicated. I might notice, once again, okay, let's check the derivative of the bottom. This would be the worst way to do it, but here's a system that will work. What's the derivative of the bottom? 8x. Can 8x be on top? No. We're missing an x, and I can never get an x. All right. Well, what else does this look like? Oh, is that guy a square? So we're going to think u squared plus a squared. I need to change color. Let's go with, oh man, orange, whichever. And now we're thinking, okay, we want u equal 2x, a equal root 3, u prime equal 2. So I need to change the top into a 2. Do it a number of ways. I'm going to factor out a negative 3. You could have multiplied by 1/3, negative 1/3. Sorry, that's what you need to multiply by. And I really did do a take where I had enough space. So we're just squeezing to the bottom now. 2x minus 3, 1 over a. Careful with the square root. Arctan u over a. Close both parentheses, plus 3. Plus c. Plus c. For those that know, 3 over root 3 equals root 3. It's because that guy's root 3 squared. Okay, so you might see that come up. You should be comfortable with simplifications like that. Practice, practice, practice. This is a perfectly fine final answer, though, for an open-ended section. Okay? All right. So unfortunately, those 3 and 4 especially are basic. 5 is hard, because 5, they worry on the multiple choice of the AP test, will the student know to long divide? Especially with the reformed AP test. More on that in a second. But 3 and 4 have to be basic to you. 5 should come to you. We've been doing long division for a while. What about 6? Now 6 is tough, but I would like you to try it out. See what you get. Try it out. 3, 2, 1. Now at this point, you're more likely to have done something wrong. And the problem is you don't know it's wrong and you just feel like it's okay to do and you cheat at algebra. Let's go over what jumps out at me. So what jumps out at me immediately is a square root on the bottom with a squared minus u squared. So everything is root a squared minus u squared. We'd like it to be like that. So that would be a equals 2 and u equals x. And that would mean u prime equals 1. But I don't have that in the top. And I can't really get that in the top either. It's not easily done. Okay, so that didn't work out. Shoot. So if you did something with arcsine, that might not be right. Depends on what else you did. Hint. Okay, well, root is also a group to a power. So what if it was like this? Does everyone see how I got that? This is a group to a power. And then this would be u. And then u prime would be negative 2x. And I can't really turn that into negative 2x. Shoot. That didn't work out either. Well, a square root is one thing. So I can try splitting the denominator. And this is really hard. I don't know why there's a capital L in the middle of that word. Split. There's one thing in the denominator. It's a root. It's a one thing in the denominator. I can split denominators. So let's split it. And that would give me x over the square root of 4 minus x squared dx. And then I'll change colors. Christmas colors. Plus 4 over the square root of 4 minus x squared dx. And now something can happen. Now that should be enough of a hint. Trying out the split is hard. After I split it though, you should be cooking. And again, why did I know to split? Nothing else was working. I'm going to try to split it up. Try this out. Try the red one. Try the green one. They are different. They are different. 3, 2, 1. Did you really pause the video though? I don't know. I'll never know. But I'll pause again and say, hey, come on. You should be able to do the red one. Here's another hint. You've been doing the red one since chapter 5, since December. All right. The red one, again, is not arcsine. If you did a squared minus u squared, u would be x, and then u prime would be 1. There's no way to get the 1 up there. This one is reverse power rule, which I already kind of previewed for you. That's the red one. I want to write it in this form, which will bring me to, okay, so the derivative of the inside of the group would be negative 2x. This is kind of sloppy. So I would need a negative 2 here. So I'm going to pay for that with a negative 1/2. That's the hook off. Don't actually erase that or anything. Don't be crazy. But then once you have that form, you can go right to here. Negative 1/2. I'm going to do my strategy of replacing the integral with the parentheses. Keep the inside the same. Add 1 to the power. Did you make it negative? Divide by the new power. Or multiply by the reciprocal, either way. I don't need to add a plus c because I still have this green one to do. Okay? Now, for this green one, now we're talking about root a squared minus u squared. If you're calling BS on me and saying, hey, they're both a squared minus u squared, I still don't get it. The x in the top is what killed arcsine here. Watch what happens here. Now we're talking about a equals 2, u equals x, u prime equals 1. I couldn't get a 1 over here. I can get a 1 over here. So I'll write this as plus. I need a 1, so I need a 4. And I'm multiplying the inside by 1/4, or I just factored out the 4. Either way, we have this minus, not plus, dx. And then, I don't know. There's a couple of different ways of notation. You can just draw the line down here, though. This is just the derivative we started with today. And now arc sine doesn't have that awkward 1 over a nonsense. I don't know. Why my writing got all crazy? Plus c. It's important that over here you can simplify this. Negative 1/2 divided by 1/2 is negative 1. Keep change flip. This is 2 times negative 1/2. That's negative 1. There's a lot of ways to simplify this. That's done. Okay? So what I'm saying with all those words, this might be the quote-unquote acceptable answer, best answer, simplified answer, the answer that's more likely to show up on the multiple choice. This is fine. Done. Okay, now for a new technique, quote-unquote new. Complete the square to find this. So the first thing I want to say is that this is the only time, well, maybe on my test, you won't normally be told, maybe on some multiple, sorry, getting tied down. You won't normally be told to complete the square. Sometimes you'll have to figure out that you need to. And when would we do this? When would we just do this naturally? When nothing else is working. Again, nothing else works. So for instance, the first thing I would always try in my mind is u prime. Sorry, this is maybe the whole bottom is u. If that's u, then u prime would be 2x plus 4. Can I get that on the top? No, absolutely not. This is not improper. We can't long divide. So the only option left on the table is to complete the square. Now, if you need practice completing the square, if you want to see this explanation in more detail, Khan Academy, you can ask me for help. Completing the square is that algorithm. You need to learn how to do it. So if this is unfamiliar to you, I'm going to break it down right now. That's why the video is getting a little long. It's almost over. So we have x squared plus 4x plus 8. Now, it's almost always going to be really simple. So we're going to call this number b, and we're going to call this number c. All that really matters is b. So b equals 4. You want to find b over 2. And so for our purposes, that's 2. And we want to find not just b over 2, but b over 2 squared. 2 squared equals 4. So then you want to write this as x squared plus b over 2, plus b over 2 squared minus b over 2 squared plus c. And then this part is a perfect square. So, with less notation, we're going to take this polynomial and I want that 4. That 4 is really important. So I'm going to write this x squared plus 4x. And then I'm going to have a plus 4 minus 4. So what I really did here was add 0, which is always okay, right? You can always add 0 to something. And then plus the original 8. I want to get the 8 separate. Because right now what's important is that this junk right here, That's a perfect square trinomial. This last number is a perfect square, and this is exactly twice that number's root, or whatever. Half this number squared is 4, however you want to say it. So we're going to have that guy factors to x plus 2 squared. I know this is unpleasant. They're going to have this on the AP test. This was emphasized over and over and over again on the material. We have extra practice for this. We'll do that in a moment. We're going to do that in person in April. -4 plus 8 is 4. So I turned this guy into a sum of squares. Okay? It should always be a sum of squares because you need it to be a sum of squares for it to be a what kind of integral. So you don't have to show all this work. This work would happen in the denominator. I'll show it again how I would show this. That's a quick breakdown. So, like for instance, I know maybe the 4 and the 8 bother you. We're going to do another example because I'm worried it was confusing. Plus 12. Okay? Something like that. What do I want? So I want 6 divided by 2, which is 3. So 9 is what I want here. We're going to do x squared. I'll use the original color. X squared plus 6x plus 9 minus 9 plus 12. I'm just throwing that in the middle. I can do that because it's just 0. And then wouldn't you know it, that's a perfect square. That's x plus 3 squared. It's always going to be this number. And then that guy is just plus 3. Okay, these don't always have to match. It matched because I'm stupid. This could have been, if this was 15, okay, let's all calm down. If this was 15, give me the pen. Then this would be 6. Okay? Could be any number here. But either way, we have a sum of squares now. If you want more practice, Khan Academy, ask me. Here's how I present my work. In general, you should try this out on this problem. We're almost done. I'm just going to write it down, and then I'll do the 3, 2, 1 count off or whatever. If I was doing this problem in a more natural setting for my own, fun, I would write it as plus 4 minus 4 plus 8. I would do all that just to show my work. But I would all do it in the denominator. That's where this is really taking place. That's the natural setting. And then I would have x plus 2, quantity squared, plus 4. And again, so now the key is to notice it's like an arc. Did you say tan? I think I heard you say tan. If you did, that was good. This is a u squared. And again, I know that's a u and a squared. I know this is u because it has the x's in it. So if u is x plus 2 and a is 2, then u prime is just 1. Wowee. I don't think I counted off, but I'm getting tired. So now we hook up there. I needed no adjustment. 1 over 2, 1 over a, arctan, x plus 2 over a plus c, donezo. Really important. Last year was a major change year for the AP test. You're going to see something like this on the AP test. We can basically guarantee it. They put it on all their practice materials. We're going to be doing lots of practice with this. Please focus. Thanks for watching. Go do the homework now. All the problems until you can do it by yourself. Focus on figuring out which one is which. Identifying what kind of integral it is more important than being able to actually do it. And I know that sounds weird or disingenuous, but it's because of how the AP test multiple choice works, right? If you can narrow it down to arccan, at least you've narrowed down your options. All right. You guys have a nice day. Have a nice night. I'll talk to you later. Bye for now.